Okay, we're now ready to put this all together. So we've learned how to construct confidence intervals for smaller samples, and by smaller I mean n less than or equal to 30, or no, n strictly less than 30. And we've reviewed how to calculate the mean and standard deviation. So now let's put this together, and we are going to actually calculate a confidence interval given only the sample data here. So it says a random sample of class sizes in a certain school district has the following sizes, and now it wants us to construct a 90% confidence interval for the true mean size of all classes in the district. Okay, so this is very much what we did before, except we have to calculate the mean and the standard deviation. Okay, so maybe over here we need the sum of x, the sum of x squared, and n. And what I'm going to do is I'm going to use my calculator here to find those sums. So I'm going to clear everything. And I know not everybody has this calculator, and we also, if you do have this calculator, I have videos on how to use it under the statistical sums videos. But if you have a TI-30 or another edition of the Casio or some other calculator, you can probably go on YouTube and find out how to do these sums if you don't remember how to do it from earlier this semester. So I'm going to hit mode 2 for statistical data, and now I'm going to put in these class sizes. So 23, 21, 26, 31, 18, 29, 33, and 25. So for this calculator, I type it in and hit M+. It puts all the data in the memory, and then I hit Shift 1, and I get these choices. So if I hit 2, that's the sum of x, 206. So that's just adding up the class sizes. So remember, this one here is squaring them individually first and then adding up the squares. Okay, and I can do it just by selecting it from the menu, hit return, and then I get 5,486. Okay, and now n is the number of values, so there's 8 values. Okay, so now the mean is just the sum of x over n. So 206 divided by 8, and it looks like I get 25.75. And I'm going to follow those rounding rules that we learned, and I want you to follow the rounding rules here. And the rounding rules for remember, for calculating the mean and the standard deviation is you go to one more decimal place than the original data in the data set. So these are all to the ones place, so this will go to the tenths place. So this will be like 25.8 is what I would get for my mean. Okay, that 5 there rounds the 7 up to 8. And now S is going to be the sum of x squared, 5,486, minus, this is the sum of x, that quantity squared, so 206 squared, divided by n, and that's 8, and then I'm going to divide that whole thing by 8 minus 1, and then I take the square root of all of that, and when I put this in, we get, so I'm putting in the top here. Notice I don't need a parentheses or anything. This will square that and then divide and then subtract. That's what you want it to do. So I'm going to do the top first, hit equals, and I get the top. Now I'm going to divide by 7 and hit equals. Now this number here is actually the variance, and I didn't mention this earlier in a previous section, but there was a problem on the homework in part 1 of the homework on confidence intervals, where they gave you the variance And if you didn't get the right answer and you're not sure why, if you look back, I think it was problem 8 on the homework. They gave you the variance, and what you have to do is take the square root of the variance to get the standard deviation. And you need to use the standard deviation in the problem, not the variance. So there might be some other problems on the homework that are similar to that. So you got to be looking if they give you variance or standard deviation. And if they give you the variance, then you have to take the square root of the variance, and then you get the standard deviation. And what I get there is 5.1. So this is my mean, and this is my standard deviation. Okay? And now what I want to do is I want to construct a 90% confidence interval. Okay? So I'm going to need my t-table here. And so what I'm going to do here is I'm going to make my interval. Okay, and I'm going to put the mean in the center, and that's what I calculated it here. Ooh, let's see, 25.8. Okay, now my margin of error, remember it is a critical t-value with n minus 1 degrees of freedom. So 7 degrees of freedom. And then on my t-table, it's a 90% confidence interval. So I go to 90%, 7 degrees of freedom. So my critical value is 1.895. So that's the critical t-value, 1.895. And now I take my standard deviation, which I calculated over here, and I divide that by the square root of n. And n here is 8. Okay. And notice that is n, that is not the degrees of freedom. So now 1.895 times 5.1 divided by the square root of 8. And that gives me my margin of error. Now I'm going to round that to the same number of decimal places as the mean and standard deviation. So I round that to the 10th place. And I get 3.4. So this is going to be 25.8 minus 3.4. And this will be 25.8 plus 3.4. And so my final interval is going to be 22.4. Now I add it to 29.2. So what I could say then is I am 90% confident that the true mean class size is somewhere between 22.4 and 29.2. So there you go. That's doing the whole problem, kind of like you are the statistician. You've taken your random sample of class sizes, and then you've done everything, calculated the mean and standard deviation, and then put together the interval. Okay, so this is a nice problem. You're actually doing statistics in this case. Okay, when you actually calculate the mean and standard deviation, if you show what I've shown here, then that is perfect. This is the work that I would want to see on a test. Put in these numbers, or find the sums, put those sums into the formulas, and get out the values there. So, okay, in the next video, what I'll have you do is actually do one of these yourself, and then we'll work on it together. So give you a little practice at doing this.